And our next speaker is Dr. Henrik Hargitai, NASA Ames researcher, and they will be talking about mapping the planet Mars.
So in this talk, I will speak about mapping Mars, but not the research process, but cartographically, in the sense of making a map, or more precisely, this atlas of Mars. Let me give you some background about me. I'm a planetary cartographer. I participated in 2 MDRS missions in Utah, and you can see me in one of the missions trying to navigate there. And I teach planetary geomorphology at Tökös University in Budapest. So this first Geographic Atlas of Mars is an outreach project. It's not a research map, but it's based on research. And it's very important that outreach and research is linked in this way. I think many of us think of a geographic map of Mars as something that should be around, but there is none in the market, and for a reason. Because just a decade ago, we simply had no sufficient data to produce a physical map of Mars. And I realized it about 5 years ago that it was already possible to make it, because we already had the pieces, but we had to put them together. I also needed some examples of the printed end product, and it was an old school atlas, or many of the school atlases I used when I was a child. Why school atlases? Because this is the first, and therefore I think the fundamental experience with maps for most of us. We learn the concept of an atlas, which is a collection of maps and other types of charts and pictures that explain the spatial relations. Now, how can we apply these designs to Mars? First, let's see what kinds of maps or layers of maps we did have before this atlas was made. And from now, we will build this atlas layer by layer. This first layer is the Photomosaic. This is the basis of all geologic maps, and this requires mostly technological expertise. If you want to produce a photomosaic, we will need an orbiting spacecraft and to take images and a lot of image processing. But there is no interpretation of the images. That's very important. You see the details, and you see many various details, but you never know if that detail is important or not. The reader is not informed about what they see. On Mars, we know that albedo features that you see here in this map reflect the distribution and thickness of dust, or fog in the case of Hellas Basin, which is geologically not really important, and yet it dominates the photographic view of Mars. What we want to show on the map is the interpretation and not the raw data. So the image mosaic in this sense is just raw data. Let's move to the DTM. From a mapmaker point of view, this topographic layer that show relief is the most important visually. If we use the terrestrial colors, like in this map actually, that will give you a false image of the nature of Mars. Terrestrial maps are designed to represent terrestrial experience of the physical geographic environment we live in, and not the Martian. So blue is for depth because it's always underwater. Green is for plains, the color of grass and forest that we usually see when we are in plain geography. Brown is for rocky mountain slopes, and white is for high mountains because it's the color of snow. None of these matches the colors of Mars. So the first task was to modify the color ramp of the relief map. I wanted to replicate the natural colors of Mars, but also to use a color scheme that's reminiscent of the colors from terrestrial maps. So that's a sort of double task here. Here is the process from grayscale DTM to the colored DTM, plus the hue shading. So from grayscale, we color it, and we add the hue shading that we automatically make using the DTM. And here is the geologic map, the next layer. Unlike the previous ones, these kind of maps are highly interpretive and require a lot of manual work. It takes about 4 years to produce a single map sheet. The problem here is that, how to put it, this map is actually the opposite of the photomosaic. It's too abstract, it's too symbolic view of the surface, at least from non-expert reader. So it's made the following way. Geologists use photomosaic and trace the contact lines. These are all the contact lines in this global geologic map. And these define the geologic units that form inside the contact lines. The contact lines separate different patterns seen on the photomosaic, And these patterns reflect differences in either composition or structure or the formative process. So these units represent uniform blocks of rocks. Geologists then categorize these units according to the formative processes, like here the impact units or lowland units, polar, volcanic units. And they count the number of craters in each unit, which informs us about their ages. So we can see these are the oldest aged units, and these are the latest, the youngest units on Mars. At the end, we can tell for any point on the surface how old is it and what process formed it. But this is a highly specialized map, like mentioned, and the general public is not simply not experienced in reading such a map. Perhaps because there is no geologic map in K-12 education. These maps are made by researchers for researchers. So the next kind of map is the geographic map that we also call physical map. Geographic maps show a very complex view of the surface. These are produced by cartographers and not researchers like geologic maps. And these maps are produced for the general public or for school children. So while geologic maps are used for scientific analysis, geographic maps are used to give you a general overview of the area, combining all kinds of existing knowledge about that region. This is why there are no geographic maps of Mars, because Mars research focuses on scientific map production, geologic map production, and it simply doesn't secure funding for geographic maps, because that would count as non-scientific. However, geographic maps use the same scientific resources as geologic maps, and therefore they can only be produced, at least I very much think that these can only be produced by planetary scientists who do know where these kind of information can be found. But scientists are, of course, busy in making more geologic maps. So how this map was born then, that's an interesting story. I worked at NASA a few years ago, and I mapped the Hellas region, but I had to come back to Hungary, where I am right now with my family. And here at my university, what we do is mostly limited teaching and outreach projects in planetary science, at least. So this is how I invented this project to make a geographic map of Mars, which is an outreach type of map, using the knowledge I collected when I was at NASA, when I made the geologic maps of Hellas and Tarsis region at NASA Ames. I got financial support from the Europlanet, Central European Hub, last year. So let's go back to the geographic map. The base layer is usually a topographic map, like the topographic map here. This is the topographic map, but colored differently than what I did. So the problem with these all kinds of layers is that you have to make first the base layer is the most important. That's because that's what we see. That's what gives the colors of Mars. So the colors are very important. I will talk about that later. Another problem is that while it's very easy to get the data for Earth layers, like the hydrology, the water polygons in this open source website on the internet, you just download it. But for Mars, there's no such place where you can download this kind of base vector layers. So you have to trace the landforms on a photomosaic and create a global database of each types of features, like deserts or peaks or glaciers, where the glaciers are, or where the ice caps are, or the hydrology or the paleohydrology of Mars, because these all are very important, and these all will be the constituents of the geographic map of Mars. There will be no cities and no roads, no administrative borderlines, but there will be some kind of linear feature. I will show you later how I invented that kind of thing that we need for our eyes to see the lines, but that will be a natural phenomenon. So most of this work, tracing the photomosaics and doing this primary research for mapping the surface features, was done in the last decade for Mars. And it's very interesting to mention that it will be done for Venus in 10 years now, in 10 years time from now. So another problem with collecting these layers is that these thematic layers are very much scattered in the literature. Some are published as supplementary data for research articles, like here you see, this is the location for this data is here. Others are published in research papers, like in tables, like here. And Geologic Maps, of course, are a very good resource for these kind of layers. I started to collect feature catalogs about 10 years ago when I worked on the Encyclopedia of Planetarians Landforms. You can see the table of contents here, a list of entries. And some of these landforms are now found as separate layers in this atlas. Now, once you have all the databases together, you need to assign a symbol to each of them, a type of line, or color, or filler symbol for polygons. So these are grouped according to formative processes, like here, impact landforms, volcanic landforms, tectonic, fluvial, glacial, artificial objects, aeolian landforms. And you see that the symbols are a little bit different from the terrestrial ones, but in all, they imitate the visual appearance of a terrestrial geographic map. Now let's take a closer look at one of these landforms, valleys. Valleys are features, and that's again very important. They're too small to be visible on a global map, either topographic or photomosaic. But they are still extremely important if you want to show the true nature of the landscape. So first you have to make an exploratory survey of on a higher resolution photomosaic, trace the paths of valleys, and then display only these lines, these vectors, on a smaller scale map or global map. And here it is at the global scale. These differently colored lines are the traces of valleys on Mars. And valleys are dry. They have been dry for the last 3 billion years. So they are not rivers. It's not the same as hydrology for Earth, but they are paleo rivers. And of course, the problem is that they are older than the oldest rocks on the surface of Earth. And some of them can even be lava channels. So what color they should be on the map? Here's the base layer, and valleys should appear somewhere here in this map. Now, blue is the traditional color of rivers, but you may instantly recognize them. But these are, like I mentioned, not rivers. These are dry valleys. That's different. Brownish color would be a good choice, but the top of this brownish topographic layer, it wouldn't be very much visible. So the color will be magenta in this case, because it's one of the direct colors in printing, which means that you can use very thin lines and it will still be sharp. The Valley database was one of the earliest catalogs, and they were made by Brian Hynek and his colleagues at the University of Colorado. I added some smaller valleys like these valleys in Jezero crater where Perseverance landed. These are the new discoveries, sort of. And I also added flood terrains, what I call flood terrains, which have not been mapped at this detail before. This is the dotted pattern. And I identify them based on island-like streamlined forms that I mapped a few years ago again. This is an unpublished work. Another thematic layer is the sandy deserts and dune fields, which is taken from this existing GIS database created and updated by Rosalind Hayward and her colleagues at USGS Flagstaff. You can drape this dune layer here over any map. And you probably know that sand on Mars is not orange, but yellow, or yellow, but black, because it's basaltic sand, like on some of the beaches in Hawaii. So to use the familiar yellow symbol for this region that we are used to from terrestrial maps is misleading, but it still works because we all associate yellow with sand. But still, it's not the representative of the color of sand on Mars. So should it be replaced by a black symbol? I chose this brownish color, but it definitely needs some improvements and at least more work. Another thematic layer is the glacially modified landforms, like here in the dichotomy boundary between the lowlands and the highlands. And these are shown in blue, and the ice caps, the permanent ice caps, which are, again, perhaps this is the only familiar color from Mars because it's white on both Earth and Mars. It's just ice. Both kinds of ice are white. There is an extra layer here that you won't find on terrestrial maps, so like the one I was talking about, the linear form that we need, the boundary of volcanic regions, boundary of lava fields or any kind of volcanic material. Because there are no other boundaries on Mars. Natural boundaries would be the coastlines, like on Earth, or artificial boundaries. And there's a topographic boundary, sort of, the dichotomy or dichotomy on Mars, which is very much visible without any line, because it's quite sharp in places. But it's shown in the base layer, the topographic layer. But the most fundamental difference is not between these areas, but between the volcanic and non-volcanic surfaces. And so this is how I justify this special focus on this boundary, like this dotted line. And the other thing is that these contain the youngest surfaces of Mars. This is the youngest part of the Martian surface, the latest resurfaced regions, fresh lava flows in Elysium Planitia. As you can see on the map, this is very smooth terrain. In these regions, you can have volcanic or magmatic heat flowing from the interior to the surface, and therefore these may or might support subsurface life on Mars in the past, or perhaps still in the present, and this makes them very important regions for in situ research or one of the next landing sites. So the landing sites, the symbol for the landing site has a special importance because these are the only objects that connect Mars to humans and Earth. Here on the upper right, you can see the landing site symbol designed from the UK. It was selected in a competition that the British Ordnance Survey organized for its first Mars map. And in my atlas, I used a very simple Wi-Fi symbol. Why Wi-Fi? Because the main purpose of landers is to transmit data from the surface, right? So the point is to show that we have radio transmitters on the surface. The radio wave symbol are black for crash landers and white for successful ones, and yellow for active missions. All these maps are organized into 30 pages according to the old Mars chart Quadrangle System, the MC quads. So each double spread in the atlas shows one Mars quadrangle. Now let's see the global maps. I made several global views using the traditional two-hemisphere projections. There are two standard views. One is this, the Albedo map, that shows Mars as it's seen from Earth or from a distance. This map is not a photograph. It's a vector map based on many different high-resolution photomosaics. I tried to color it with colors that approximate the true colors of Mars. The other standard view is the topographic map and the polar views. Now we have a scientific map here, the Geologic Map, that shows the rock types. I used the color scheme, and that's again an interesting story. It was inspired by an old Soviet era maps, which were designed by Kira Shingaryova. And I worked with her in the past, and it's important because her group at MIGAIC, it's important from cartographer point of view, because so at MIGAIC University in Moscow, that was the first group who designed a cartographic comparative atlas of planets in the solar system and the moon. So this is again a first of these kind of works. And the colors and patterns in my Geologic Map are taken from this atlas, but the actual data is from the 2014 Tanaka et al. Geologic Map. Now here's a historic map from the 19th century. And this map was made by the Italian Giovanni Schiaparelli, who first made the cartographic maps of Mars, not this one, because at that time the standard Mars map were drawings that were as realistic as possible. Now, Schiaparelli was the first who decided to apply or imitate the visual technique of terrestrial geographic maps, like this one, sharp lines and symbolic colors, and the complete nomenclature he invented and we still use today, the place names. So I merged many of his maps that he made at different oppositions, different years, to get this global view, and we projected them to match the other maps, and north should be up and south is down. On this same page, in the lower part, I tried to construct a sort of identity for us planetary cartographers, in that I collected the major figures who contributed to the early mapping of Mars. It turned out that the first drawings of Mars, there were female astronomers, and one of them was the assistant of the famous American astronomer Percival Lowell, and her name is Rexy Leonard. She is here, and you can, this page might serve as a first version of Planetary Cartographer Hall of Fame. And I really like to continue this work, to discover our past in a way. And finally, the climate conditions of Mars, a temperature map. This is an entirely new work. I used actual measurements plus the climate model by the French scientists Forget and Milour. This theme is again based on the school atlases, where they typically include climate maps and climate diagrams. And since such things didn't exist for Mars, they needed to be constructed again. So I created the global temperature map for summer and winter, like these ones, and climate zone maps and the climate diagrams. So the diagrams show the daily highest temperatures and daily lowest temperatures at ground level at 2 meters high, which is different. And I also constructed some cloud maps where I merged daily photographs by the Marcy camera of Mars, photomosaics, and it gave us the cloud patterns which are different for the 4 seasons. So weather is perhaps not as diverse as on Earth, but there are fronts, storms, morning fog that you can see here, afternoon clouds, orographic clouds, wave clouds, the polar hood in the northern part or the southern part during the winter and after the winter. And there are lots of things, except one, which is very important: there is no rain on Mars. And here's the calendar. There are many geography themes calendars on the market. So the plan is that we will have this Mars Atlas issued for every 2 years, every 1 Mars year, with different maps and different content. And there are 3 different editions so far, all published in 2021. And all for Mars year 36. The first was in Hungary. The second edition is the UK edition, and this is the third one in Turkey, in Turkish language. And the drawings were made by my daughter, so we can call it a family business, this Mars Atlas. And to summarize here, in some types of maps, human decisions play little role. Such maps are albedo maps, photomosaic maps, and DTMs that are already available. This map, however, is the result of many human decisions, like what to include, what color, what symbol to use, how to combine them, and so on. So this is the difference between this geographic map and single layer maps. So finally, let's go step by step through the phases of Atlas production, from this grayscale DTM, adding the color, hill shading, valleys, rills, volcanic lava channels, caves and cones, volcanic cones, troughs and scarps, tectonic features, the highest peaks, linear feature labels, which is again important, the typography here, polygon labels, volcanic region boundaries, the albedo names. There's a separate layer of nomenclature for the albedo, the different albedo features, and the geographic grid, and the marginal content for a map. The same for the albedo map. That's the basis, the Albedo Mosaic. I traced the different values of different strengths of albedo, and I created this color map and adding the grid and the nomenclature, and it looks like this finally. Thank you for your attention.
Thank you very much, Dr. Hargitai. This is very interesting. And the first question we have is obviously, when might your atlas be available to the general public?
It's already available. The year 36 edition is available through Etsy. So if you search Google, then you will find a way to purchase this atlas. But in Hungary and in the regions where it was sponsored by Europlanet, we sent it to schools and amateur astronomer clubs. And the plan is that there will be a next edition next Mars year in 2 years' time, and that will be available from the US for the US market.
Wonderful, thank you. And the second question or comment is, do you intend to only keep it as a physical book? It would be really useful to use a Google Earth-like online globe where the user could switch between layers.
You're right, you're absolutely right. So, like I said, the basic idea is school atlases that you must hold in your hands. So that's the old school reading book experiments. But you're right. Well, Mars Track is one of your platforms then, where you can find these layers. Some of the layers that we made are transferred to Mars Track. So these, like the hydrology or paleo valleys, are already there. And yes, Google is not providing vector layers yet. It's a little bit tricky, and so the technology is more complicated than doing physical printed Mars book. But probably by the time school atlases will go full virtual, this atlas will also be available virtually.
Thank you very much. And next question is from Stuart. Great work. Do you consider making an icosahedral project? Buckminster Fuller did one for Earth, which you could cut out and make into a globe.
Yes, we have globes. We have virtual globes. But yes, I made several very tricky projections, and that's the maximum that we will do. That probably in the next edition we will add some exotic projections, but only in printed form.
Wonderful, thank you. And let me just ask you a very quick question about maybe future plans or plans for future editions. What are the areas or type of areas that are yet to be mapped, or something that you would like to be on the next edition of the Atlas?
That's a very good question. Actually, of course, where the heat is, so the Elysium area is a very interesting one, because this is where you see the volcanic, the latest volcanic activity. So to zoom into that area, that would be, I think, a good idea in the future.
Well, thank you very much, Dr. Hargitai. And time's up. We definitely recommend everybody to take a look at the Atlas, and very excited to see what the next editions would be like. Thank you.